Welcome to the Surgical Theater. If you're studying for your Cambridge examinations, specifically the 0606 additional mathematics syllabus, you know that tackling polynomials isn't just about crunching numbers. It is about precision instruments and steady hands. Today, we are going to dissect these complex questions with absolute surgical accuracy. Think of me as your chief strategist. We are going to build your ultimate mathematical toolkit to break down the factor and remainder theorems so you can walk into that exam room and guarantee top marks.
Here's our operational plan for today's session. We'll start with Section 1, looking at ancient mathematics and how it applies to polynomials. Then, Section 2, multiplying and dividing. Section 3 is graphing to find roots. 4 covers the massive factor theorem shortcut. And finally, Section 5, the remainder theorem. We've got a lot of ground to cover, so let's get right into it.
Section 1, Ancient Mathematics and Polynomials. Now, let's set up the challenge we face in these exams.
See this abacus? It's an early calculating tool from the Han Dynasty. It represents raw, unfiltered calculation. And honestly, this reminds me of a student I worked with recently. Let's call him Alex. Alex is brilliant, but he overloads his exam answers with raw mathematical facts. He just throws numbers at the page like he's flicking beads on an abacus, but with zero analysis or structure. And then there's Sam. Sam rushes. Sam completely misses the specific command word requirements in the question and loses massive marks because of it. If we were to look at their past papers side by side, it's just a sea of red pen marks. We need a better way.
The problem of unstructured calculation isn't new. Take a look at this ancient riddle from Sun Tzu, posed way back between 544 and 496 BC. There are things of an unknown number, which when divided by 3 leave 2. What is the smallest number? If Alex tried to solve this, he'd write 3 pages of random division. If Sam tried it, he'd guess a number, write it down, and skip the method marks entirely. But Sun Tzu's riddle is actually the ancient forerunner to the remainder theorem we'll be mastering today. To solve things like this in a modern Cambridge exam, we have to decode the command words first.
And that starts with having crystal clear definitions. Precision in terminology is your first rule. A polynomial is categorized by its order, which is the highest power of the variable. An x squared is a quadratic, an x cubed is a cubic, an x to the power of 4 is a quartic, and x to the power of 5 is a quintic. Identifying the order instantly tells you how many potential roots the equation might have. This is step 1 of dissecting the question.
Section 2, Multiplying and Dividing Polynomials. This is where we reveal our core strategy. Multiplying polynomials is a highly structured process, and it perfectly mirrors the framework top students use to structure their mathematics answers. We call it the PO framework, adapted for math. Point, evidence, explanation, link. Your point is the mathematical rule. Your evidence is showing the expansion, taking each term in the first bracket and multiplying it by every term in the second. Your explanation is the methodical collecting of like terms. And your link is stating the final simplified polynomial clearly. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's keep building this strategy.
Now, dividing polynomials is where we really see the surgical precision come into play. A lot of students attempt messy, long division here, but top-tier candidates use a technique called equating coefficients. Look at the setup. We know a cubic divided by a linear factor like x plus 2 leaves a quadratic, which we write as ax squared plus bx plus c. By carefully comparing the coefficients on the left side of the equal sign with the right side, we systematically unlock the values of a, b, and c. It's like a puzzle. You find the x cubed term, then the x squareds, proving your evidence step by step. This is exactly what examiners are looking for.
Section 3, Graphing to find roots. Let's look at the incredible transformation that happens when you apply this structured blueprint.
I had Alex and Sam rewrite their answers for a graphing question using our new framework. Before, Alex would just scribble random coordinates everywhere. Now, he sets up a methodical table of values for a cubic equation, mapping out the x-coordinates from -2 to 5 and meticulously calculating the y values. You can literally see their mark potential skyrocketing. They plot the coordinates on the axes and draw a smooth, continuous curve. No jagged straight lines between points. That's a classic mistake that loses marks instantly. And here is where the red pen marks transform into green check marks. The geographic x-intercepts on your graph are exactly the same as the algebraic roots of your equation. When the y value is 0, those x values, -1, 2, and 4, are your roots. Sam used to miss this connection completely because he didn't read the command word deduce. Now, he clearly links the visual crossing of the x-axis to the mathematical solution. That's the Peel framework in action.
But be warned, Cambridge examiners love to throw curveballs. Sometimes the graph only gets you close and the roots aren't neat whole numbers. You'll have to rely on trial and improvement, hunting for fractional roots between the integers. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4, the factor theorem shortcut. Welcome to the interactive workshop part of our session. Get ready, because I'm going to put you on the clock.
Challenge 1. The data scan. Look at this comparison between algebraic long division and the factor theorem. I'm putting 60 seconds on the clock right now. Look at how much working out is required for long division versus the theorem. What is the core trend here? The trend is time management. In a high-pressure exam, algebraic long division works, but it eats up precious minutes. The factor theorem is your precision scalpel. It bypasses the clunky division entirely, so you can test potential factors in seconds. Time is up. Did you spot it? Challenge 2. Find the flaw. The factor theorem beautifully states that if you plug in a value a and the polynomial equals 0, then x minus a is a factor. Now, imagine Sam writes this on his exam. Because f of 3 equals 0, the factor is x plus 3. What is the flaw? You have 10 seconds to spot it. Right, he messed up the sign. If f of positive 3 is 0, the factor is x minus 3. That single sentence just caused Sam 2 accuracy marks. The theorem is a two-way street, but you have to get the signs right. Challenge 3. Speed writing. You need to hunt for that first linear factor by plugging in factors of the constant term until you strike 0. I'm giving you 30 seconds to mentally write out a perfect Peel paragraph on how you'd solve this. Clock starts now. You should be thinking, point, use the factor theorem. Evidence, test f of 1, f of negative 1, etc. Explanation, show the substitution that equals exactly 0. Link, state, therefore x minus a is a factor. And time's up. If you can structure your thoughts like that under pressure, you are practically invincible.
Section 5, the remainder theorem. This brings us to the final system, the ultimate cheat sheet to guarantee top marks.
The final system boils down to 3 rules. Rule 1. Command word decoding. Always know exactly what the question is asking. Rule 2. Peel framework application. Structure your working out so the examiner can't possibly dock you marks. And Rule 3. The time management matrix. Using tools like the remainder theorem instead of long division. The remainder theorem lets you substitute a into your polynomial to instantly find the exact leftover without doing a single line of actual division. It is the ultimate time saver.
Take a complex cubic divided by x minus 2. You just calculate f of 2, and boom, the remainder is exactly 17. 2 lines are working. Maximum marks. Listen, students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
Let's wrap this up with a real beast of a question. We have an unknown a and b, a factor of 2x minus 1 and a remainder of 5 when divided by x minus 1. You decode the command words, you set up your 2 simultaneous equations using the factor and remainder theorems, and you systematically solve it. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.